Okay, we're working on problem 95, and our goal in problem 95 is to rewrite this expression, d of t equals 10t squared, using the slope of 5 and 5 plus h. Okay, so our slope formula, as we know, is y2 minus y1 over x2 minus x1. Now we notice from looking at our graph that x is t, or time, and y is d, or distance, in this problem. And so when we go to write our pairs of x1 and y1 and x2 and y2, we're going to use the axes that we have. So let's start with our first pair. x1, actually, let's do a color for that. Let's do purple. x1 is equal to 5, and so then our output, or y1 for that, is equal to the output when we plug 5 in. And so when we look at our expression, we have 10t squared, so if we put 5 in for t, 10 times 5 squared, we get 10 times 25, which is 250. And I've sort of simplified our graph by taking some of the information off of it, but we just found that point, the point 5, 250. So we can write that as an ordered pair. 5 is our x1, 250 is our y1. Sorry, that's an x. Okay, let's talk about our x2, which is 5 plus h, which means our y2 is going to be the output when we plug in 5 plus h. Now again, we're looking at our original function of 10t squared, so we're going to replace t with our x value. So we're going to have 10 times 5 plus h squared. Now we can evaluate that to be a single number, but you'll see that we've now written our second ordered pair. So we can write that ordered pair as 5 plus h is our x1, and 10 times 5 plus h squared, is our, x2 and y2. Second ordered pair. Okay, and now all we need to do is just use this expression up here to calculate our slope. So we're just going to plug it in. For y2, we have 10 times 5 plus h, the quantity squared. We're getting that here. And, here. And then y1 was up here, so we're going to subtract that, which is 250. And that gives us the difference in our y values, which is this height right here of the slope triangle. We're going to put that over x2, which is 5 plus h. And then we're going to subtract x1, which is 5. And that gives us the difference of our x values, which is the base of the slope triangle. And now our job is just simply to simplify that. Careful, when we have 5 plus h, the quantity squared, that means we need to do an area model. Ooh, I'm running out of room here. I'll do it over here. 5 and h and 5 and h get multiplied to be 25, 2 5h's, and h squared. So if we rewrite that, we have h squared plus the 2 5h's added together are 10h plus 25. Don't forget that we need to multiply it by 10 and then subtract 250. And then when we look at the bottom of the expression, we see 5 minus 5, so that just simplifies to h. Now, we can distribute the 10, so when we do that, we get 10h squared plus 100h plus 250. And then we can see that the plus 250 and the minus 250 cancel out. So if we rewrite this expression, we have 10h squared plus 100h all over h. And since there's an h in every single term, we can get rid of those. And our final expression becomes 10h plus 100. So that is the slope expression that we're looking for. The question is, how is that helpful to us? Well, if we look back at the original problem, we wanted to find 3 different values when we had, t equals 5, and then h equaling these different values of 0.5, 0.1, and 0.01. And instead of having to do the slope expression for all of those, we can now use this expression to calculate each. So let's start with 0.5. We're just going to plug 0.5 in for h. Half of 10 is 5. 5 plus 100 is 105. That actually looks just like the output we got when we did the slope expression. Next one, 0.1. 10 times 0.1 plus 100. We're plugging it in again to 10h plus 100. 0.1 times 10 is 1. We get 101. Again, matches our previous calculation. And we'll do 0.01. 10 times 0.01 plus 100. 1/100th of 10 is 0.1 or 0.1 plus 100, so it's 100.1. Again, that matches our calculations. And all of these we were calculating in feet per second. One thing that I want to point out in this is, what is our h standing for? And h stands for just the difference between x1 and x2, or we call that the change in x. So for the first blue one that we calculated, we had 5 as our original x, and then 5.5 as our second x, and the h value then was just the difference between them. Okay, so h just stands for the difference between our first x value and our second.